just finished making a video about critical periods in development for vision and for language. Now I want to verbalize my learning as it relates to Hebb postulate, or Hebb postulate, sorry. I get the pronunciation wrong sometimes. So basically, Hebb's postulate is realizing that neurons build their networks through, I'm going to actually use the formal definition. So coordinated activity at presynaptic terminal and postsynaptic neurons strengthens the synaptic connections between them. So basically, as neurons begin to build stronger synapses that they respond to stimulants in congruence with each other, the more they do it, the stronger those connections become and the faster that they become fitted. And we've gotten close to really understanding the mechanism by which that happens in learning centers of the brain. So the phrases that work with Hebb's postulate are cells that fire together, wire together, and that cells that fire out of sync lose their link. And not only that cells that fire together, they wire together, they also increase their speed and their strength and their ability to hold on to those connections over time. So this relates to neuroplasticity because when you're first born in development, your neurons are pretty much all connected to each other. You have way more connections than you'll ever need in your lifetime. And so the challenge of being a newborn is actually not building up to experience your world. It's actually focusing enough on your world to distinguish different parts and ascribe meaning to things that are relative to meeting your needs in your environment. And so a lot of the neurodevelopment in infancy is actually pruning the brain's connections down and making connections that are meaningful stronger so that they can be recalled in the future. And a lot of this process happens in the learning centers of the brain. So examples of this is, I think, if you're I brought up an example in class that, if you have some sort of thing communicating to you that you have a need for potassium in your system, and you happen to eat a banana, and all of a sudden the brain center of your brain that associates with everything to do with the banana, like being yellow, having a banana smell, the sense of pulling the banana apart, and now the sense of getting potassium in your body. So you now fulfilling your need for potassium and banana, those neurons have fired together and they link together. And over time, the more that you satisfy that need of banana, the more likely you are to crave a banana the next time that you need potassium. Those links have bonded together and they're now part of the learning that you co-create into your mind. The other example is me learning about Hebb's postulate. So I've seen words on text, I've listened to words, the more similar that those words are, and the more that I use them, they connect to other parts of my brain, and the more that I keep thinking about Hebb's postulate, or just learning not to call it Hebb's postulate, the more I keep saying that over and over, the more practice that I've done, the more likely I am to get that right in the future, because those neuron connections are going to be stronger than the others. So kind of now explaining the mechanisms by which these connections become stronger and faster, and by which they can actually weaken with disuse. So use it or lose it is another aspect of palsy. So if you used to be a gymnast, you used to be able to do flips and everything, and then you have a long period of not doing that, you're not going to be able to connect your muscles back into that level of muscle memory because those neurons' connections aren't as strong as they used to be. One of the mechanisms that does that is specific learning neurons that have a special receptor called MD and A that has to be unlocked in order for excitatory ion channels to be brought up to the top of the cell in order for that neuron to be activated. So if that receptor is activated frequently, within 10 minutes or so, it's actually going to bring those ion channels up to the surface, and it's going to allow the ions to channel through and work through. And the more frequently in which that is stimulated, it will actually divide up and make more sites for iron receptors to go through. With disuse, however, it will turn back to putting those ion surfaces below the surface of the synapse so that they're not available. So the more that you activate those neuronal connections, the more accessible that channels are going to be, the faster that they're going to react with each other, and the more opportunities it's going to create. If you do the opposite, it's going to reverse the process, and those neurons aren't going to be as easily activated. So that's basically the understanding of Hebb's postulate and the mechanisms of neuroplasticity.